In many trig textbooks, you'll see the unit circle given, this magical circle with all this information on it that students seem to think they need to recognize. You don't need to memorize even. You don't need to memorize it because you can figure it all out. Here's how, right? Earlier in the course, we saw the two nice triangles, half of a square, and if the side length of the square was all ones, the angles, of course, are all pi over 2s, and cutting in half, I get pi over 4s. So pi over 4, pi over 4, pi over 2 are the angles, and if this is 1 and 1, I can take this square root of the sum of the squares to find the hypotenuse there being the square root of 2. So I can get all the trig functions of pi over 4 because I know that triangle. Likewise, if I had an equilateral triangle where all the side lengths are the same and all the angles are the same, the angles, of course, would be pi divided by 3 because the sum is always pi, and if they're all the same, you divide by 3. So anyway, and then you cut that in half to get pi over 6. So the pi over 6, pi over 3, pi over 2, right triangle. I chose to call the side lengths here all 2 because I knew one of them was going to get cut in half. So this is 1, that's 2, and then use Pythagoras. 2 squared minus 1 squared is 3. Take the square root. Square root of 3 is that side. Now I can see all the 6 trig functions of those. And we did this when we were defining, we did this earlier in the quarter. We also then used those to find trig functions of big angles, some of the nice big angles. But now from the point of view of the unit circle, let's take a look at the angle of, say, 5 pi over 6. So 5 pi over 6 is going to be out here somewhere, right? 6 pi over 6 would be pi, so I'm pi over 6 short. So this is the pi over 6 angle. This is that reference angle right there. Now, what I would typically do to find the sine and the cosine of 5 pi over 6 is right here. I would drop a perpendicular down to the x-axis, and then I'd recognize that this triangle that I just created is this one right here with the 1 right here and the 2 right there and the square root of 3 over here. But since I'm in the second quadrant, the x-coordinate is negative. And so the sine of that angle is 1/2. The cosine of that angle is minus square root of 3 over 2. But now, from the point of view of the unit circle, we don't want just any point on the terminal ray. We want this point on the terminal ray, and we want the x and y coordinates of that point. Well, the unit circle has hypotenuse 1. So the hypotenuse of 2 has to be scaled down to hypotenuse of 1. So, cut everything in half. Take the 1, cut it in half. Take the minus square root of 3 over 2. And cut it in half. Now, if you look at the chart that's in your book of the unit circle at 5 pi over 6, you're going to see an x-coordinate of minus the square root of 3 over 2 and a y-coordinate of 1/2. Right? Is that something you need to memorize? No. Because you know this triangle right here. You put it in there, you put the angle you wanted, you drop a perpendicular down the x-axis, you say, hey, I recognize that nice triangle. Oh yeah, it's not a unit circle because the hypotenuse is 2, so scale everything down. Whatever the hypotenuse is, divide by it. So that was for the angle 5 pi over 6. How about 5 pi over 4? 5 pi over 4, I think of, there's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. So I'm sticking down here in the middle of the third quadrant. Drop a perpendicular, right? Side lengths, 1, 1, square root of 2. Except that this is negative, and that's negative because I'm in the third quadrant. So I can see that the sine of 5 pi over 4 is going to be minus 1 over radical 2, and the cosine is going to be minus 1 over radical 2. Oh, but this isn't the unit circle because I don't have a hypotenuse of 1. So scale it down so you do have a hypotenuse of 1. Well, if I just took the hypotenuse of radical 2 and turned it into a hypotenuse of 1, then I divided by radical 2. So take this one and divide by radical 2. Take the one on this side, divide by radical 2. It's getting kind of busy here. But this length right there would be minus 1 over radical 2. So the coordinates of this point are minus 1 over radical 2, minus 1 over radical 2. Right? You could find that on your chart, but you don't have to find it on your chart because you can create it right here. You can do this. I knew this triangle, and so I've got that. There are 3 nice angles in each quadrant. There's your pi over 6, there's your pi over 4, and there's your pi over 3. Each one of them drop a perpendicular down to the x-axis and recognize, oh, this one right here, it's this triangle down here, but with the pi over 6. The next one would be this one with the pi over 4 right there. And then this is again this triangle down here, but the pi over 3 is the angle. And in the second quadrant, you've got this one, and the one I drew. And in the third quadrant, this one, and this one, and this one. And in the fourth quadrant, it's just this triangle or that triangle, and then scaled down. Divide by the length of the hypotenuse, right? Which really shouldn't be too surprising, dividing the length of the hypotenuse. Sine and cosine are each opposite divided by hypotenuse. Adjacent divided by hypotenuse. And so to scale it down to have hypotenuse of length 1, you just divide by the hypotenuse. In that way, you can find the coordinates of each one of these points. And in finding the coordinates of each one of those points, you are finding the sine and cosine of the appropriate angle. Okay. So there you go. There's the unit circle scaled down from our nice triangles.